Alright, what's up guys? It's streaming time. And this is the wrong project. Rimio V2. Alright, so we left off. So I was experimenting with 16-bit floats right there. We left off, right, starting on the particles. Oh, and I forgot to change the video title, but we're still working on particles, so that's fine. So, let's figure out what we were doing. What we did before was we got the, let's see, where is it? In terrain pipeline, we set up a new buffer for the particles, and also let's see. We also set, oh yeah, we added a new bind group entry. Alright, let's do a test run. That always helps me remember what's going on. Alright, while we're waiting for that to compile, I'm going to change, oops. The window just opened up 1 second. I'm changing the video title. More particle programming. Okay. Oops, and I gotta zoom in too. Okay, zoomed in. Right, let's retry running the program. Here we go. So right, I increased the movement speed a little bit last time. It's about 3 times faster than it was before, which is much nicer. Pretty much we're just generating a sphere here. And the intention right now is to put particles into these octree leaf nodes. So to make that happen, first of all, let's get rid of all these unused imports. Ugly, ugly. I wish in Rust there's no way to automatically remove unused imports yet, which is quite annoying. And also, like, I don't even get why that would not be a thing. But, oh well. Oops. Okay, that's all of it. Or that's all the unused imports. So the thing we've got to do right now, first of all, I think, oh right, that's what we were working on. In the game module, we have to go and generate some nodes. And, oh, actually we already did that. So for now we're just going to generate random nodes, just placed in a random area near the spawn point. And then we need to upload them to the octree somehow. So here's the thing that we have to work on. This is going to be, we have to figure out some sort of structure, like acceleration structure for this data. And I'm thinking, actually we've already implemented it. Okay, I think the first step right now is we have to go into octree builder. Octree builder needs to know about the nodes. So when we say build, we're going to add a parameter, particles, and that will take a list of particles. Okay. Actually, hold up. So, time to change the name of the stream again. Separating CPU and GPU. Wait. Decoupling CPU and GPU octree representation. Okay. So that's what we have to do right now. Currently, the octree is represented, or it's stored in a buffer. It's stored in a buffer of nodes, and there's also an object or a struct called octree start, which contains the information about the root node of the octree. But this is quite an ugly way to represent it, because it like very tightly couples the CPU implementation, which is very powerful, to the GPU implementation, which is quite limited. And since a lot of the work is going to be done on the CPU side, that kind of sucks. So, yep, we're going to have to implement octree on the CPU separately. However, this is a very good thing. Even though it is duplicating code, it's going to give us a lot more freedom to just change things, do things how we want to, and also reduce a lot of friction, just as we're writing. So the way we're going to do this, we're going to have to make a pointer-based octree instead of a buffer-based. And my hope is that the pointer-based octree will be a lot faster to serialize into a buffer-based octree, but without having to be stored as a buffer all the time. So we can do like our CPU side operations on it as pointers, which might include allocating more nodes, reorganizing things, and etc. And basically it's just a lot less limited than if you're storing everything in a tightly packed buffer. However, we are potentially going to be throwing away we might be throwing away some performance by doing this, but it's going to make it so much more easy to reason about. And I'll program it in a way, I'll try to program it in a way that it is like easily extensible or replaceable. So if I decide in the future sometime that I don't want this pointer-based octree anymore, I should be able to replace it pretty easily. And you use interfaces and mostly interfaces to do stuff like that, or what Rust calls traits. That way you can just implement a trait for some arbitrary type. You put the functions on it, and then you only interact with that type through the trait. And then in the future, if you want to say, oh, I don't like how the data is stored, you just make a new struct, and then you implement that type for it, or the trait for that struct, and then you use that struct instead of the other one, but nothing breaks because you're only using it through the trait implementation, or through the trait interface. Okay, that was all useless information, but fun to rant about. So the current thing that we have to do is we gotta define a node type, pub struct node, and I'm actually going to have to probably, one sec, sneeze. Oh my lord. Okay, probably going to have to access the shader crate node type through the namespace and to not import it. Oops, there's another missing or unused import there. Oh, and that's because I just defined pub struct node. So node, what's this going to contain? Node will it's going to have to be self-referential because It's a recursive pointer-based data structure. So let's think about the data that's going to need to be stored in Node. The first thing I think is we're gonna have to have a list of we're gonna have to have a list of what are they called? Okay. Well, first of all, children. This always happens to me. Like, I know what I'm talking about, but when I try to say it, I forget what it's called. Or I know what I'm thinking of, not what I'm talking about. So children is going to be probably a box containing an array of actually self. And is that legal? Is that allowed? I think so. And actually we want this to be sized. We want there to be 8 elements. Do we have to put that before or after? No, I think it's after. Oh, self and numbers just happen to be colored the same way. Interesting. Aside from that, so we need the children, which is like it just contains the next 8 children in the octree. And you also need, what's that thing? Oh, particles. We need a list of particles that this octree is going to contain, which will be stored as a vector, I believe. Now that I'm thinking about this, it actually does seem kind of disgusting. I'm not sure how efficient this is going to be. I think, you know, a linked list thing I think is going to be a better solution. And if we do linked lists, I guess that's still going to, it's not really going to matter as much if we store the octree this way. I don't know. Octree's the one thing that just hurt my brain. I despise octrees. But they're the only solution for making such fast ray tracing acceleration structure. And the hard part is making them modifiable in real time. That's scary. Okay. So apparently we're not doing the pointer-based octree. Okay. So are we just gonna do the linked list thing? I guess so. Let's go into okay, well here's a question. Do I want my octree to be general purpose, or do I want it to be for particles? I guess it can be general. Can it though? Okay, well this is not how we're going to want it to be in the future. But for now we'll have octree builder take a list of nodes in the build function. I don't know why I called that nodes because this is definitely supposed to be particles. Also, that is the wrong function. Oh, good lord. Okay. Particles. Go to octree. Oh, yeah. And particle. Although it probably still would be a good idea to well, I don't know. There's like a cool optimization that you can do if you keep the the octree and, or sorry, if you keep the CPU and the GPU side coupled, which is that you don't have to transform the data when you send it to the GPU, you can just copy it straight in, which is super handy. But also, like, it's just a development concern. I keep forgetting to name the type here, or the parameter. Particles. Okay, here's an issue. So this is a threaded implementation, meaning we might have to spawn. Okay, so so since this is threaded, this octree builder is a threaded implementation. We might. I'm losing my thoughts already. Cursed octrees. So, what was I even thinking of? Oh, right. So the list of particles. When we're generating based off of the particles, each particle has to go in a specific octree node. Or like, so we start at the top of the octree when we start building the octree. And it's just one node at first. And then it splits up into 8 more nodes. And then it splits up in, each of those splits into 8 more, and each of those splits into 8 more, and so on. So basically we've got this list of particles, and when you do the initial split into 8 separate nodes, each of those is going to be on its own thread. But we have one list of particles. So the issue is, how do we determine, alright, so basically the naive way to approach this would be to take the particle list, spawn all the threads, send the particle list, or put the particle list in a mutex, send it to one thread, and then that it finds all the particles that need to be in that node, and then unlock it, send it to the next thread, or lock it in the next thread, find the particles that need to be there, unlock it, lock it in the next thread, find the particles that need to be there, and unlock it, and so on. But the problem with that is, first of all, you have to go through the entire list for every single node, which is not ideal. Especially as your octree starts dividing more and more into deeper and deeper levels, you're going to be traversing through that entire list a ton of times, and that's not great. The other problem is that you're going to have a ton of thread contention because you're locking this one big central resource in an algorithm that's supposed to be super parallel. So one way I'm thinking that we can solve that is to first of all sort the list. You'd sort it into 8. Actually, no, split the list. You'd split it into 8 different like cubes, one for each of the child nodes. And then you'd send that split list into the child, or into the children, into the recursive function gen. And for each level that you go down, you'd look at all 8 of the nodes and find out which particles go to which of each of the node, and then you only pass those particles into each of the child nodes. Then you're going through a smaller and smaller list as you get deeper and deeper down into the tree, and it's only relevant particles. And that sounds really good. But the issue with that is you're going to be copying a ton of data. So if you have like a big data set of particles, so right now particles are, let's see, right now there's 2 vector 3s in it, and a little bit more data, pretty small data. So let's just say there's going to be 4 vector 3s per particle for now, to be safe. So a vector 3 is made of 3 floating points, or 3 32-bit floats. So 4 times 3, and each float is 4 bytes times 4. So each particle will be about 48 bytes. Let's say 64 bytes to be safe. Let's say we multiply that by 1000, and we'll say bytes. So that's 64 kilobytes times 1000, 64 megabytes. Actually, that's not that bad. I was thinking that we wouldn't even have 10,000. I was thinking probably 10,000 particles in the world max. This is actually not bad at all. Maybe we don't have to worry about it so much. You know what? I'm just going to go for it. I'm just going to do the copying for now. In the future, a possible optimization we could do is we could sort the entire list beforehand, and then we could just use a slice out of that initial list for each child. And that would prevent needing to copy data. Hold up. So the data, basically theoretically, it's going to get copied once for each level. So if we have 64 mega, actually, that's not so great. Whatever. It's still not bad. What's 10 times 64 megabytes? 640 megabytes? Oh, actually, that's pretty bad, but it's not too bad. It's okay, I think we'll survive. Oh yeah, another issue that was on my mind is that the octree currently has a shared implementation, or a shared data layout between the GPU and the CPU, but the particle list does not. But maybe that's not a problem. A lot of particles. So this is still going to be shared or stored as a linked list. Position, velocity, mass. I mean, actually, you know what? I could potentially just upload this entire thing to the GPU. It wouldn't put a dent in it. Because, again, 64 megabytes, that's nothing. That's nothing compared to what games these days load in your graphics card. We could potentially just move this to the GPU. Let's put it in here. We'll just put it in octree for now. It should not be an octree in the future, but this can be its temporary home. Okay, we're gonna have to implement bytebug types, which means we have to derive clone and copy. Then unsafe impl byte muck pod for particle, and unsafe impl byte muck zeroable for particle. Oops. But it does help to spell it right. So these would all become public. Ah. Oh man. Okay. More corona notifications. Also, this should not. Wait, hold up. Oh. We got our stuff scattered everywhere. Okay, this should not be here because it's ugly right there. I'm gonna move it down. What the heck? Oops, we did that. I accidentally middle clicked again, which copy and paste something. Okay, we're moving this down to here, next to node. My mistake. And this is also a public struct. So branch node. Branch node, we're just gonna have it. Actually, no, this is gonna get its own class because, let's see right here. This can get its own module because octree does not have to be tied to particles. Oops, we already have that. Particle.rs. Position, radius, material ID, next. Okay. So we'll have to add material ID on here. And that'll just be a U32 for now. What the? Oops. This is not, this is Rust. This is not Go. What was the other thing we had? Oh, next, right? We have to have a reference. Headphones turning off again. Okay. Next, so since this is going to be a linked list, we're going to have this as relative particle index, and it's going to be pub particle. Okay, we're going to define a type particle, or relative particle index. Oh, actually, a relative particle index is going to be actually, let's not do relative indexes here, or indices. We'll just, oh, I already had something defined there. Pub type relative, not relative, particle index. It's just going to be 32. So this is just going to store the absolute position to the next item in the linked list. So we can make an implementation for particle. New. Actually, I don't know if we need an implementation here. Not yet. So in our terrain, what happened here? Oh. So one thing that might get kind of weird is storing the mass on the GPU side, because that means that I'm going to have to calculate the radius based on the mass. On the GPU every frame. It's weird. It's weird trying to share the implementation on the GPU and the CPU. Okay, what are we missing here? Velocity. However, a cool thing about having the velocity stored on the GPU side is you can do cool transformations like stretching out a particle based on the direction that it's moving, which is pretty cool. So it could be nice to have that. mass is the only thing I'm worried about. I could potentially actually even change this to radius. And we'll just derive mass based on the radius of the particle. But actually I don't think we need to worry about that yet. Particle, let's also have velocity and material ID is 0, since we don't have any materials yet. And, oh, I think we have to import this. And the other, next. So next right now will be 0, representing there is no next. And this should have a semicolon. So now when we build the octree with the particles, we have to actually do something with the particles. So first thing is first. This is going to potentially slow down the implementation. However, we're going to have a lot less particles than we'll have to generate noise. So it could also speed it up. Okay. So we're not going to use noise anymore. What we're going to do now is generate the, we'll turn on a leaf node based on whether there's a particle present inside of it. So we'll say, first of all, we have to take another, okay, we're going to get rid of the noise parameter, and instead we're going to take a list of particles. Particle slice, not node, particle. And we might have to import that. No, I think we already have it. And then this is going to take in particles. So we'll comment all of this out because we don't need it anymore. Oops, actually we can even comment this out. Ah. Okay, this is all old stuff. So now, let's leave a comment for ourselves. A leaf node turns on if there is a particle present inside this node. So now we have to figure out how to tell if the particle is present here. The way that we do that is, first of all, we have to get the bounds of the current node. So, also let's change this here. This has to be particles. Oh wait, actually, I'll get to that in a sec, because that requires some more attention. Okay, first of all, find the bounds of the current. Oh, never mind. It's actually really easy to find. So, it's actually just offset plus 1. Okay, let's min or bounds. Actually, do I have like an AABB type defined? I don't think I do. Anyway, bounds min is just equal to the offset. And bounds max is equal to offset plus vec3 1. And actually that'll be uvec3. Actually, I'm going to convert these to, let's see, convert them to float vectors, because the point that I'm going to be comparing against is a float. You know what? There's we can make this easier for ourselves. We should implement like an AABB type, like util.rs pub struct AABB. AABB will just have a min field, which will be a vec3, and a max field, which is a vec3. And we're gonna have to go into main.rs, include that as a module, mod util. And this is probably not going to stay in util forever because util is a very non-descriptive name, but it'll go here for now. Implement our vec3. and then impl AABB. So first function pubfn new. This will just take a min and a max, returning self, and it'll return, oops, self with min and max. And the most important one is pubfn collide, and this will take self, and it'll also take an other parameter, which will be a reference to another self. Oops, and it should not return self, but it should return a bool. So this will return whether or not two axis line bounding boxes are touching each other. And I think the way you get that is called something like the separating axis theorem or something. But basically, you see if the right side is greater than the left side of, I don't know, it makes more sense in my head than I can like elaborate. But let's see if I remember how to do this. Self. So if self.x, wait, self.min .x is greater than other, oh, oops, wait. Self.max.x is greater than other.min.x, and self.max.y is greater than other.min.y, and self.max.z is greater than other.min.z, and the other way around. Wait, is this right? Hold up. This doesn't feel right. You know what? We can use our good friend the internet. Separating axis theorem. Normally I think I'd be able to figure this out myself, but my brain is just like died right now. I want them to show me a nice picture. Okay, that's all box. You know what? You know what's even easier? We can open up Krita. We can just draw a picture for ourselves. File new. Alright. So let's say we got box 1 right here, B1. And then we got another box right here, B2. Now, we can tell, obviously, that they're intersecting because box 1, the max side is greater than the min side for box 2, right? But then, here's another question. What if there was a box like this? Now, the minimum is less than the maximum here, right? But this is called B3. But the maximum is also greater than the minimum. Right? Right? So, and this would be colliding if it was like up here. Let's just imagine that he's there, you know. This is a very scientific drawing, by the way. So, if this one, I don't know, man, how, I just wrote this the other day in like JavaScript or something, and I totally forget how I did it. Okay, I was totally thinking about it wrong. Right, I get it. So if the minimum of box 1 is greater than the maximum of the other box, then obviously it's not colliding. So you're not trying to find out if it is colliding, you're just trying to find out if it's not colliding. Okay, there we go. So if self.min.x is greater than self dot or other dot max.x, then obviously it's not colliding. And or self dot min max.x is greater than or is less than other dot min dot y. Yeah, okay, I think that's it. So basically if all these come together and are this ends up as true still, then you'd return false. So the output of this would be not all of this. Right? Self.min.x or yeah, I'm pretty sure this is right. If it's not, then oh, Sunny, what's up, my guy? I didn't even see your chat. Yeah, oops. See, look, I'm going crazy right here. That's supposed to be an x. Self dot min dot y is greater than other dot max dot y, or self dot max dot y is other less than other dot min dot y, or self dot min dot z is greater than other dot min dot max dot z. System.out.println. Ah, yes, Java, good times. Write me a program right now. Write me a program in chat. How about, let's see, let me give you a program assignment. Okay, I'm giving you a boolean. No, I'm giving you an int x. If the int is greater than 5, print out epic. And if it's less than 5, less than or equal to 5, print out bad. There's your program assignment. Type it in the chat. I know you can do it. What the heck happened here? Also, you don't have to type the class stuff. You could just do the inside of the main function. You don't even have to define x. I gave you x. It's already present in your program. Here, wait, I'll type it for you. And x equals 100. Okay, self.max.z is less than other.min.z. Alright, there's our implementation. So cool. Now we don't have to define these two wacky variables. We can create our own cool box. Oops, that's a keyword. AABB equals AABB new. And then we just set up the min and the max being offset and offset plus offset dot as f32 and offset dot as f32 plus vec3 1. Oh yeah, have you gotten into if statements yet, Sonny? I probably should have asked that first. But yeah, programming, very fun. Very fun. So, oh, I didn't even need to write that function yet because what I actually have to do, I totally forgot about, is we have to make another function, pub fn is point inside or something along those lines. I could probably rename that much better, but point will be a vector 3, returning a bool also, and this is the same as before, but just a lot easier. Self dot min dot, okay wait, point is less than self dot min dot self dot max dot x, and point is greater than self dot max min dot, oh my god, my poor brain falling apart, point dot x, self dot min dot x. Okay, I can probably be quiet for a second. Okay. That is if a point is inside. Not yet. Ah, I see. Actually, practicing programming just solo by yourself on YouTube or on the internet or something is really fun, and you'll learn a lot that way. Um, it's actually, I recommend that you just grind programming at home and then you just breeze through your classes because you can learn a ton when you're just practicing it by yourself and like actually doing it yourself. At least that is my experience. Okay. What's next? Okay, so the point, we're gonna have to go through all of the particles for particle in and particles, and we're gonna have to determine whether it's in the AABB. Actually, we're gonna have to do that for 8 different axis line bounding boxes. Yeah, that's fine. We'll just do this for now. And we'll just do this for now, but I'll leave a note for myself to do. Horribly inefficient will kill your computer. Hopefully that will remind me. Okay. What do you program? Oh, there's so many cool possibilities. I would recommend actually programming games is the best way to learn in my opinion, or because games are really hard to program and they pretty much apply all the different, like they apply a lot of different fields that you usually use in professional programming into a single program. So you end up practicing a ton of different stuff when you do game development. So starting with like a console game is a pretty good way to do it. Like, I don't know, taking text input and then saying like, oh, blah, blah, blah. I don't know. Reacting to text input is fun. All right, let's see. Public static void main string args. So yeah, just a print statement so far. Right. Well, have you gotten to defining variables yet? Actually, here's a cool thing that you can do. I'll teach you about how to do math and programming. It's like, here, let me make a new file. We'll set the language, Control KM, set it to Java. So, let's imagine that there's a class around here. So, to define a variable, all you gotta do is you put the type of the variable, and the most basic type is like int, short for integer. It's basically just a whole number. And then you type the name of the variable, epic variable, then you put an equal sign, and then you put whatever you want it to be equal to. 1,000, 10,000. Oops, I can't save it. But then you can make another variable, int cooler variable equals 2. And then you could make another variable, int sum equals, and then you just type epic variable plus cooler variable. And you could do int, what do you think? Like, what's it called when you multiply two things together? Product equals epic variable times cooler variable. So cool. And then you can print that out. System.out.println epic variable. Or not epic variable, but sum is the one that we want to print. And that wouldn't be in quotes because you don't want to literally print out the word sum. You want to print out the value of this this variable. So do you have an IDE installed on your computer right now? Like Eclipse? Because you could try this out right now. And it's very fun to play around with. There's other data types. There's like float. I don't know. Basically a float represents a decimal. And you can have like 100.5. And this is used to put numbers with higher precision than just whole numbers. And then there's string. String gamer equals a cool gamer. And a string is basically what you print out in system.out.println. I don't know. That is a pretty good introduction. I don't know. I know you're already doing this stuff, but yeah, I highly recommend you open up a program and just try it, because that's how you'll learn the most, is just by doing it. Plus, programming is really fun. It's like more fun than video games for me. I guess not everybody could say that, but I think it's quite entertaining. Anyway, where are we at right now? Oh yeah. So this piece of code looks kind of evil. JGrasp. What is JGrasp? I have never heard of this software. Let's look at images. It had better be so pretty. I hope it doesn't still look like this, because this is pretty ugly, TBH. When did this come out? Huh. Ooh, site's looking modern. Yeah, programming's really fun. Another thing you can do is you could get VS Code, which I really like, but it is a little bit trickier to set up for Java. But because you have to do stuff through command line, but it's actually a pretty good learning experience. I actually don't know how to do it off the top of my head. I'd have to look it up. um, to, and this is VS Code, it's this editor here. But it's very pretty, I like it very much. You can use it for any language. I've used it for C++, Rust, Java. Those are the main ones that I've written in the past. Oh, and I just used C# in this. But yeah, VS Code, very good editor. I'm not sure if I've run my program in a while. I want to see it. Oh, never mind, it's under surgery right now. Cannot really run it. So I am worried about performance here because I'm going to have to run a for loop for 8 separate child nodes, and then I'm going to have to run another for loop in each of those iterations for each particle, which is kind of terrible. Yeah, Java's actually the first program that I started with, or the first programming language. It's a pretty good first language. And it's also really cool because it has built-in functions for rendering graphics and opening a window. And that's like, it's super nice because it makes it accessible to start making like, stuff that's actually cool where you can like look at it and see it doing things and stuff. Uh-oh, hold on, my grandpa's calling me. Oh, I'm back. Oh, bruh. My headphones do this thing where they turn off if there's no sound coming in, even if I'm talking. And that happens like multiple times per stream, unless I put on some background music or something. But music is kind of distracting sometimes. Okay, I gotta write my for loop. So for particle, actually there's another way we can do this. Well, that's actually complicated. For particle in, what am I doing? For I in 0 dot dot 8. Wait a minute. Oh, I only have to do this once. Oops, I already had this set up. I lost my train of thought and got confusioned. Hmm. Let's close out of here. So maybe the linked list thing should not actually be a part of the physical particle class. Maybe that should be like a separate thing that wraps the particle struct. So we'd have derive, clone, and copy, and also obstruct particle. What would we call this? Particle reference? And it would just contain a particle. And a reference to the next particle. Oh, my grandpa again. Alright, just gonna code quietly for a minute because talking makes me think bad. Oh, wait, that's pretty cool. Particles is not mutable, so we don't have to put it in a mutex. We can just take a reference even though it's in a different threads. That is very nice. Alright, have a good one, Sunny. And good luck with your classes. Oops, forgot to import the trait. And that gives us some new errors. Oh, of course, these have to be mutable. The writer traits have to take immutable self. Otherwise, how can we write to ourselves? Actually, I'm not going to make this return anything right now, because that simplifies things a lot. We just have to say let particle equals self.0 at self.0 at parent index dot. Does that not work? Oh, as usize dot next equals self.0 at parent index as usize. Oops. Does that work? Expected U32. Oh. Okay, I'm actually surprised that that does not throw errors, but I'll take it. Dude, my headphones are really annoying me. I gotta put on some sort of background noise. Wait, let me make sure that my desktop audio is off. Okay, so what's wrong right here? Okay, I have to take this as mutable? Okay, that actually works. Another thing that we're going to want to have in the future is fn regenerate or something along those lines. but we'll write that later. But basically what regenerate would do is this is going to be really fast to have all these writes to it. It's just going to have it's just going to be append only, which keeps things really easy. And then every so often it'll just do a full it'll just go through the entire tree, or not a tree, the entire linked list, and it'll just like reset it, or it'll rebuild it without all the different spaces interspersed through it. It'll just be easy. So I'm kind of scared of using this because I feel like it's going to cause me a headache to test this. What the? Hmm. Okay, that seems like it's better. Yeah, I am getting hungry. My brain is slowing down. We've gotten a lot done though, and on top of the actual coding, I've done, I don't know, I think I've gotten a lot of like theorizing done, which is good. Okay. Let's try to wrap it up, I guess. Actually, I think this is a good stopping point. I'm gonna add my commit. And let's do a line count. Clock, src, and shaders slash src. Alright, we're at 1764. Getting up there. I'm so excited to just be able to start like making gameplay because it's gonna be so cool. Anyway, time for a break for me. Peace.